In this video, we're going to be looking at using the u-Substitution method to calculate definite integrals. So integrals that have a lower and an upper limit here. And when you have definite integrals, your answer is always going to be a number. Now, your TI 84 Plus calculator, there is a way you can calculate this on that. However, your math professor might specify that you show your steps and you show what you got for u and all the steps. The answer, like in this second one, could involve a radical, and your professor says to give the exact answer, that a decimal approximation is not allowed. And say on the ACT, you're not allowed to have home programs that give you a radical form of a decimal. So you're going to need to know this at some point, how to do it without a calculator. So that's what we're going to do today. I'll use the calculator to check my answers, okay, but I am going to show you how to set this up for u-Substitution. Okay, so we're going to start with this one. Okay, and I've got another video on indefinite integrals, so you might have seen that already. When you're looking at using the substitution method, you need to be familiar with derivatives. And so when I look at that, the first thing I think, well, the derivative of that is 2x dx. And we've got an x dx there. So, and of course the derivative of a number by itself is just 0. So I'm going to rearrange this. And I'm actually going to take this constant and I'm going to put it out the front, because if it's part of a product, you can do that. Okay. So I did say that I wanted u to be what's inside the parentheses here. Now I'm going to take the derivative of each side. So the derivative of u with respect to u is just 1 du. And the derivative on the right side with respect to x is going to be 2x minus 0, so 2x dx. And notice here I just have x dx. So I want to get rid of that 2. And so how do I get rid of the 2? Well, I'm just going to divide both sides by 2. Dividing by 2 is the same thing as multiplying by a half. So that will cancel, and I'm going to have a half of du is x dx. All right, so this here is 1/2 du. Okay. So I'll do, before I write this up in u, there's one more thing we have to change. These limits of integration are with respect to x, and I need to change them with respect to u. So what's happening here? X, where shall I write it? X is going from 1 to 4. But now what are the limits on u? Well, we said u is equal to x squared minus 6. And so the limits are going to be 1 squared minus 6 up to 4 squared minus 6. And so 1 squared is 1, 1 minus 6 is negative 5. And 4 squared is 16, and 16 minus 6 is 10. All right, now I'm ready to write this thing with respect to u. And I'm going to do it in red. So the 12 out the front is coming along for the ride. And now instead of x going from 1 to 4, u is going to be going from negative 5 to 10. And then I'm going to have u to the 5th. And then the x dx is 1/2 times du. And again, 1/2 is just a constant, and it's part of a product, so I can move it out the front. Okay, now I'm going to switch back to black. 12 times a half is 6. And now I can integrate this just using the power rule. So 6 is coming along for the ride. And u to the 5th, when I integrate that, I'm going to have u to the power of the original exponent plus 1. And then out the front, I'm going to have a fraction and 1 over the original exponent plus 1. And then that is going to be evaluated from -5 to 10. Okay, so nicely, conveniently here, the 6's cancel. And so that's going to be 10 to the 6th minus -5 to the 6th. And at that point, I would probably just let the calculator do it. Okay, let me just write that out here. 10 to the 6th minus -5 to the 6th. You cannot cancel those two negative symbols. Don't ever do that. These two negative symbols here, because these parentheses, the 6th power has to be done first. Okay. If you didn't have the 6th power there, you could have canceled those. But as it stands, they will not cancel. Don't do it. You'll get the wrong answer. Okay, so I want 10 to the 6th minus -5 in parentheses. Sorry. Let me clear that. 10 to the 6th. Then I have to scroll over 1. I need to clear everything. 10 to the 6th. I have an older model handheld one, and you don't have to do the scrolling over. So minus, then -5 in parentheses to the 6th power. Okay, that's what I want. And so my answer will be a number, and it's 984,375. Okay. Now I'm going to check my answer. I'm just going to use the calculator to check it. Okay. So I'm going to press the math button. I'm going to come down here to there, function integral. I think that's the one it is. Yeah. So the original went from 1 up to 4, and then I had 12 times x squared minus 6. Then x squared, and then scroll over minus 6, then to the power of 5, and then times x, and then we want dx. Okay, I think that looks right. And now I'm going to press enter. Okay, so that checks out. That checks out. So lots of professors we all know that you know, you can just get the answer. So if you're allowed this on a test, we're not going to ask you for the answer. We're going to ask you something like, you're going to have to show your steps. Okay, so I'm just using that to check. Okay, on to the next one. Alrighty, let's start. Well, when I see that, that's the same as that, yeah? And if I take the derivative of that, it's going to be minus 1 times x to the power of -1 minus 1, or that. And see, this right here is that. So I'm already formulating a plan on how to do this. So first of all, I'm going to rearrange it. I'm going to put the square root stuff first. And I'm going to rewrite that as x inverse. And then I'm going to rewrite that as x to the negative 2. Okay, so I'm thinking now, let's let u be what's inside that square root symbol. Because the derivative of 1 is 0. Okay, so it should work out pretty nice. And again, a way a professor can ask the question, they can ask you what's the exact answer. And this is a very complicated radical. It involves more than, it's a sum of fractions of radicals. And so, you know, your calculator is going to give you a decimal approximation. So that's one way a professor can make sure you know how to do the steps. On the ACT, this question, you would not be allowed to have a program that you programmed yourself to take a decimal and radicalize it. So let's just continue. I'm going to take derivative of both sides. So the derivative of u is 1 du. And then the derivative of the right-hand side, well, the derivative of 1 is 0. And then the derivative of x to the negative 1, or negative first power, is going to be negative 1 times x to the power of negative 1 minus 1. Okay. And that's almost what I want. I just need to get rid of that negative sign. So I'm just going to negate both sides, or multiply both sides by negative 1. So now these negative signs will cancel because I don't have a power up there. Okay, looking good, looking good. Before I write this with respect to u, I need to change the limits. These limits are with respect to x. So x is going from 1 to 8. So what about u? Well, I've let u be equal to 1 plus x inverse, or 1 over x. And so that's going to go from 1 plus 1 over 1 to 1 plus 1 over 8. 1 over 1 is 1, and 1 plus 1 is 2. 1 plus 1/8, well, if I rewrite 1 as 8/8, then 8/8 plus 1/8 is 9/8. That's what I'm going to do. So I have my limits for u. Okay, I should be ready to write this all in terms of u, so that there is minus du. Okay, so my new integral will be 2 to 9/8 times the square root of u times minus du. Okay. Now, the minus sign can go out the front. Okay. I'm going to probably now go to, the minus sign can go out to the front. Now, 9/8 is a smaller number than 2. So I've got the large number as my lower limit. I'm going to swap these limits. Now, when you swap the limits, the integral is negated. So I have the negative sign from the outside, and I'm going to swap these two limits around. And when I swap the two limits around, I'm going to have another negative sign. And see, those two are going to cancel each other out. And so now I have, oops, sorry, my bad. And so now I have, I'm going to put that up here. So now these cancel each other out. And I have the square root of u times du. Now I'm going to rewrite the square root as the 1/2 power because I'm going to use the power rule. Okay, so using the power rule, this will become u to the original exponent plus 1, 1/2 plus 1, which is 3/2. And then out in front you have multiplied the fraction 1 over the original power plus 1, so 1 over 3/2. And then this is being evaluated from 9/8 up to 2. Okay. Now, I can simplify. If you have 1 over a fraction, it just flips the fraction. Okay? So 1 over 3/2 is going to be the flip of 3/2. So 1 over 3/2 is 2/3. I'll put that down here. And that's going to be evaluated from 9/8 up to 2. So I'm going to have 2/3, and then I'm going to have 2 to the 3/2 minus 9/8 to the 3/2. Okay, now that's an exact answer, but still, probably want to use radical symbols. Okay, now 2 to the 3/2 is the square root of 2 cubed, which is the square root of 8, which is the square root of 4 times the square root of 2, which is 2 times the root 2. Okay. And then I have minus, and then I've got to do 9/8 to the 3/2. So 9/8 to the 3/2 is going to be the square root of 9 cubed, which I'm going to write as 9 squared over 9, over 8 cubed, which I'm going to write as 8 squared times 8, which is 4 times 2. Yeah, I'm just trying to write it as a radical. So instead of 8 cubed, I'm going to write 8 squared times 8, which is 8 squared times 4 times 2, because what I'm trying to do is I'm going to have the square root of 9 squared times the square root of 9 all over the square root of 8 squared times the square root of 4 times the square root of 2. So that'll be 9 times 3, so I'm going to get a 27 in the top. And then in the bottom, the denominator, I'm going to have square root of 8 squared, 8 times 2, which is 16, then times square root of 2. Okay, so all right, so I'm just trying to get it written exactly, because this is what professors will do. They'll say, what's the exact answer? Okay, so I've gotten to there. Let me make some room over here. Okay, now I got to multiply the 2/3 through. So I'm going to have 4 times square root of 2 over 3 minus, and then 2/3 times this. Okay, 2/3 and then 27. So the 3 and the 27 will cancel, and I'll have 2 times 9 for the numerator. And then I'll have 16 times square root of 2 in the denominator. Now the last thing they might do is they might want you to rationalize it, where I'd have to multiply numerator and denominator by square root of 2. Also, 18 divided by 16. 18 is 9 times 2, and 16 is 8 times 2, so that does simplify to 9/8. Okay. Lordy. Okay, so I'm going to have 4 times square root of 2 over 3 minus 9 times square root of 2 over 8 times square root of 2 times square root of 2. 8 times 2 is 16. That is the exact answer. Now, how do I know that that's correct? I'm going to check it. Okay, let me make some room and get my calculator up here. And I'm just trying to make some room here. Okay, so I'm going to do that 4 times square root of 2. Then divided by 3. Then minus 9 times square root of 2. Divided by 16. And then I'm going to press enter. Okay. Now, how do I know that's the right answer? I can check it. I can put the original problem I was given here. So I'm going to check it with the original problem. So 1.090 something. So I'm going to press the math button. And then I'm going to come down here to number 9. So 1 to 8. And then we have 1 divided by x squared. And then we have the square root of 1 plus 1 over x. And then I have to scroll over. And then we have dx. Okay, that looks like what they have there. Okay, so the moment of truth, I'm going to press enter. And I like that. Okay. All right, so after all of that, because this is really easy to make a mistake here with these numbers, but it came out all right. So if you had this problem, say, in a textbook, and you looked up the answer in the back, they wouldn't be giving you a decimal approximation. They would be giving you the exact answer, and the way I've got it there in the box is how it would be written. And yeah, so there are lots of ways that a professor can ask you for an answer, whereas just putting it in there and getting a decimal isn't going to get it. They can ask for the exact answer. They can check your calculator like with the ACT, and you're not allowed to have any written programs of your own. You can use the factory programs, and the factory program won't give you the exact answer to that, at least not today. They might have some newer models soon that might do that. Okay, so sorry if this video got a bit long, but yeah, I thought it was important to show you how to give the exact answer. So I'm going to stop the video there, and you can check out some of my other videos. I do integration using substitution when you have trig functions, when you have exponentials and everything, so you might check them out as well. All right, thank you so much. I'll end the video here.